In the last video, we talked about the XBee Series 2 radio and really introduced how it worked in the API mode. We also have another video which discussed how it worked in the AT/transparent mode. But now I think we're ready to move on to the next step, which is using the API mode in a more robust fashion. So how do we actually use this thing? And really the best way to exemplify that or to demonstrate that is to use an example. So we're going to jump into an example here where we're going to essentially just query a radio and retrieve its firmware version as well as the channel that it's operating on. Now this may not seem like an especially difficult task. It's not, but it's also a really good starting point for working with the API mode and developing Python scripts that are able to access parameters like that. So it's going to be difficult to perform these type of advanced tasks in Python without still using AT commands. But instead of implementing those AT commands from the X-CTU terminal or using some other external terminal emulator, we're going to do it in Python. And we're going to take this Python script, upload it to our Connectport X2, and then let it run. So for this purpose, like I said before, what we're going to do is we're going to try to acquire the radio's firmware version as well as the channel that it's operating on via Python. And the AT commands for this are going to be VR, which gives us the firmware version, and CH, which gives us the channel number. Now, the most important resource for this type of work is going to be the Digi XBee developer page. I have a link in my Word document there. I really suggest you become familiar with that if you're going to be working with the XBee radios. And so now let's actually jump into the code and see how this example works.
There are two main commands that we're going to use in this code below. One is going to be DDO underscore get underscore param, and this allows the developer to retrieve any information from the radio's configuration, including all the information that's displayed in the X-CTU application. Now, if you click on the Digi XBee developer page, you can see there's really good documentation on the DDO get param method, the purpose, description of how to use it, and the values that it returns. I only brought this up just to give an example of a good documentation page that Digi provides. All right, so jumping back in here, the second command we're going to use is struct.unpack, and this allows a developer to extract individual bytes from a string containing multiple bytes. And this is going to be useful in taking information we get from DDO, get param, and using it. Okay, so this is a Python script I developed, get radio configuration.py. And what it does is it uses AT commands, accessing parameters VR and CH to retrieve the firmware version as well as the channel of the XBee radio at a given address. It then displays this information to the user. So we get two parameters, VR and CH, and then we display that information to the user. Okay, step one, we have to define the main function to be called. So everything that we're doing is going to be included in here. Step two, we are going to import the functions DDO get param, DDO set param, both of those from the library ZigBee into the current namespace. And so that is done right here specifically. DDO set param is the same as DDO get param, except it allows us to set parameters instead of retrieving them. Now, I think I may have included that library in an earlier version of the code. I don't think we end up using it. But anyway, it's no harm, no foul. We imported it. We don't really need it. Okay, step three is going to be to define the address of the target device or node. In this case, we're going to be using the X2 gateway radio's address, but that's really not important to this example. And you can see that the address is listed right here. Step four, we are going to use the DDO get param command to access the radio's configuration, as done in the X-CTU application. So pretty straightforward here. We define two variables, fware and channel. Then we use the DDO get param method 2 times. Both are going to employ the same address, but they are going to specify different types of AT commands or different parameters to access. But all of them have 3 pieces. You have your method, you have your address, and you have your AT type. Next, in step 5, we're going to print the length of the output. Essentially, we're just finding the length of the fware variable and printing that to the user. So if you have any questions about this part of the code, that's probably more of a Python question as opposed to a Digi or XBee question. Then we display the channel info to the user. You can see we have the print statements there. But the firmware version that we displayed to the user is a raw output. So the question I ask up here is this raw value useful? Now, we can use, in step 6 we do it, we can unpack the output using the struct.unpack method. And what that's going to do is take our firmware version, which is 2 bytes, okay, and it is going to unpack it into 2 separate bytes. We're calling B0 and B1. Now, we have to give this struct.unpack method 2 different inputs. One is the format that it should expect, 2 bytes, and then the value that actually needs to be unpacked. For the channel, it's a little bit easier because it's just a single byte, but we're going to be unpacking it to B2. And then step 7 is to print the output. So byte 1 of the firmware is this, byte 2 of the firmware is this, and then byte 1 of the channel, which is the only byte, is shown. And then lastly, you can't forget to call the main executable. Now, let's take a look at the values that it returns. Okay, so here we have the output. The firmware version is 2 elements or bytes long. Makes sense. The raw firmware output, if we display it, looks as it's in a hex form and it's only showing one of the bytes. So it's not really, you can see one of the problems with displaying it in the raw form is that unless we do some post-processing or refine our print method, it's not going to show it to us in a very nice way. In fact, if we look at the firmware version that we expect, it should be 0, well, it should be in hex 21A7, and you can see we're only getting the last 2 or the last byte in hex. We're going to fix that in 1 second. We see that the channel output is 1 byte, 1 element long. That makes sense. And the value that it returns is 14 in hex. And that is correct, because if you look right here, you can see that our channel is 14 in hex. Now, let's take a look at this piece down here, everything from here onward. And this is our unpacked information. So now, these 2 statements, sorry, it's really small, byte 1 and byte 2 of our firmware returned. So it takes the 2 bytes, it separates them, and then we're converting them and displaying them as integers. And so what we see is the value it gives us is 33 and 167, which corresponds to 21 and A7, which in base 16, right, is 21A7. In base 10, it's 33,167. And if you look here, you see 33 is the first bit, that's 33,167. So it actually returns the proper value to us in an unpacked base 10 form. Now, it really doesn't make sense to look at the firmware in this integer form. It makes more sense to refer to it in the hex. But anyway, you can see that it's displaying it to you properly. And then the channel, now unpacked and converted to an integer form, is 20, which is the same as 14 in hex, right? Because 14 is going to be 1 times 16 to the 1 plus 4 times 16 to the 0, which is 16 plus 4 equals 20. And so our both versions of our channel, whether it's in hex or whether it's in base 10, those agree with one another.
So that brings us to the end of the first example. We use the DDO get param method in order to acquire the firmware version of the channel on which our radio, which in this case was the Connectport X2, on which the radio was operating. We displayed that information to the user, and everything matched the reference, which we get from the web interface. We're going to go ahead and jump into another example straight away. And in this one, we're going to develop a program in Python to locate and identify all the networked S2 radios. Now, I know that this may be done using the Connectport X2's web interface. However, we want to learn how to do this in Python so we can integrate this code into larger scripts or larger pieces of software that we're trying to develop. And so what we're going to do is take a look at a function called getNodeInformation, which returns a tuple of 3 arrays containing the node types as well as their extended and shortened addresses. And let's go ahead and just jump into that example.
So the code for the example starts right here. Name is fun get node information. And it starts right here. We've already gone over all of the details of what it's trying to do, so we don't have to repeat that. Okay, so jumping into the code, I'm going to start off talking about it in more detail, and then I'm going to sort of trail off a little bit, only because it gets a little bit repetitive. And I think that once you see the pattern that we have forming, it'll become clear how it continues. I'm going to try to hit on the most important method calls, API calls, and go from there. Okay, so let's jump in. You're going to need to obviously, import your libraries. Okay, we're going to be using DDO get param and get node list, and also the library struct. Here, we're setting a couple parameters that we will use later on. So refresh prompts the connect port to perform new device discovery every time, not use a cached list. This clear variable prompts the connect port to clear all devices from the list before performing a discovery. And then we'll see in a minute what discover digi is. It essentially just tells the export. We're going to use it later in a function call to actually perform the discovery. Okay, this bool print results Boolean variable just allows us to turn on and off displaying results to the user, which I used in debugging a little bit. Okay, now here, the first big function call, we're creating array node list from the get node list method, and we're passing, you can see, several of the Boolean values to this function, essentially telling it to refresh every time, to clear the existing values from the list, and then also to actually perform that task. Okay, so that gives us this array node list right here, which we are going to use later. Next, we're going to create 3 empty arrays, one to store the node type, one to store the node address, and one to store the node address short, the 16-bit address. And so this is the information that we're trying to extract from every single node. We're going to start a loop here, which is going to be a while loop using k1 as an iterative variable. So the while loop will shut off when k1 reaches the length of array node list, or the number of elements in array node list. Okay, so now we enter the actual loop. Okay, and so step 8 here, we want to convert this next element from a array to a string, which is done here using the str command. We display some values to the user, and we increment our loop. Step 11 asks us to split the string with a space delimiter. Now, why are we doing that? And here's where you'll see sort of the continued pattern that emerges. What we're doing is we're taking an array, we're converting it to a string, string, and then splitting it to pull out not only the individual elements, because if we just wanted to pull out the individual elements, we could just leave it as an array. But we want to split those individual elements, and so we're using the split functionality that's associated with strings. Okay, so now that we've split array node list 1 into individual pieces, we are going to start a second loop, which is going to cycle through the individual pieces of array node list 2. So what you see is that it's a recurring pattern where we have list, let's say this is list 0, almost you could call it, okay, and that gets turned into a string to become list 1. We then take list 1 and we split it to create an array, which is list 2. We then are going to cycle through the elements of list 2 and convert that to a string, which becomes list 3, and then later split that. So you can see this is the way that we are going to be able to parse the values of essentially what's returned in the very beginning by get node list right here. So this is a little bit more of instruction on how to use Python with a little bit of some API mode Python thrown in there. Okay, so we split this time according to the equal sign, which is now going to allow us, instead of picking out the individual nodes, is going to allow us to extract the values themselves, right? Because they are all written with, for example, address equals, and then you have XYZ. So by splitting according to the equal sign, what we're doing is pulling that and making those two separate elements, and then we can pull this element out and put it into, for example, either array node type, array node address, or array node address short. Okay, so we create our array node list 4 by splitting array node list 3, and then we start a new loop. We are cycling through the elements of array node list 4, as you can see right here. Then we're going to convert array node list 4 to a string. We are going to split it according to the bracket, okay, and this you expect to see at the beginning of an address, which is normally displayed as, right, something like that. And so all of these splits, again, not to be repetitive, are just pulling out the values that we need. So then we continue. We start a new a new loop based on list 6. And we keep going down and down and down, splitting further and further. And you can see here we split according to the end of the address bracket, or the bracket at the end of the address. And so what we're doing is we're slowly pulling out the information that we need. Now, is there a shorter way to do this? Probably. This is maybe not the most eloquent code I've ever written. I think that it was written in pieces as I needed to get more information out. And so, yeah, it's the use of the embedded loops is definitely not the most eloquent code that I've ever written, but it works. And so you can see we keep drilling down, down, down. We again convert our string to an array, and then eventually we start looking for the individual parameters. And so because of the ordering of these, because of the ordering of the nodes and as well as the ordering of the values, what we see is that when K2 is equal to 3, K3 is equal to 2, K4 is equal to 2, and K5 is equal to 0, meaning we're in the first iteration of that new loop. That is when we can pull out the address. And so what we do is we add a bracket, open bracket, the address, close bracket, and then we append that to array node address. The next thing that we're going to do is, because there's 3 different arrays we want to fill. We want to fill the type, right? We want to fill the address, and then we want to fill the address short, which is the MY parameter normally. Okay, and so next we need to acquire the shorter network address. For that, we are going to use the DDO get param. We're feeding it the address for this node that we're talking about, and we're extracting the MY parameter. We have to unpack it as we did in the previous example, and we are going to append that MY value to array node address short. So now you can see that we have added in two different places, 1, 2, we have added values to our address and our address short arrays. The only thing left to do is the type. And that is the last piece right here, where we essentially extract the type and append it to the list. And so for this one, there's really not much splitting that needs to happen. We just know that because of the ordering of the values, and if you implement this code yourself, you'll see why these specific indices are chosen. The main difference between here and here, you'll see, is the value. So we have 3220, and down here we have 2210. So that is the difference which allows us to get either the address or the type, and then we return the tuple of values shown here. Now, because this function was stored within a module named dNodeInformationPy, the following executable was used to call function getNodeInformation. The code, along with sample results, is shown below. Okay, and so the call is relatively straightforward. You can see it just calls the function, no input passed to it. It returns a tuple, and then it displays the tuple back to the user. And so you can see the results here of those shown. We have the addresses as well as the types shown. And it seems like in this, yeah, so up here, we didn't choose to display the short addresses, the MY addresses. And anyway, if you showed that, it would show a similarly coherent result. And so that brings us to the end of this section. Next, we're going to talk about some relevant Python methods and coding techniques that will help us using the API, and then we'll move on to some more advanced examples.